We just get it done.
My name is Anna Steffi, and I am part of Group 19.
I'm Zach Barnett in Group 19.
I'm Alana Judd Wallace, also Group 19.
I'm Donlin Jai, Group 19.
And this is our video for recitation 13. So this is kind of a long one. We start out with a bucket and a well, and we're not given any data points at first. It's just R, M, I, things like that. And number one is we're applying the AMP to find the bucket's acceleration as it descends the well. So let's see. That's what I got. Negative RMG I.
Yeah, I think it's the same.
Yeah, I was looking. I'm trying to see how we both simplified it. You did put it in vector form, so I like yours better. I realized I didn't put it in vector form at all. So I think we agree. Did Zach or Gia get anything different than this or anything like that?
No, I got the exact same thing. I just didn't simplify it as much, to be honest.
Mhm.
Where she has delta V over delta T, negative MGR over all that stuff, that's where I stopped. So I could have definitely simplified it more than that, but I kind of conflicts.
Mm.
Yeah, I didn't quite get the first part of the question, so no, I'm just trying to see how you guys did it.
Mm.
Yeah.
Okay. So oof, too far in. So for part 2, we're using the energy principle bucket. We're trying to find the bucket speed just before it touches the water, dropping a distance h. So, okay. I have 2gh. I think ours are the same again. They're just differently simplified. 1 plus.
Yeah, it's the same.
Okay, I can't, I'm bad at mental math. I have to write everything down. Okay. So yeah, the energy principle, breaking down these components, the work is just through that H. We have the speed. You isolate it from these known factors and you just push it all to the side to get your speed. Anyone have anything different?
No, I simplified it all the way this time. I got the exact same answer as Alana.
Oh yeah. In part 3, the momentum principle is in play to describe the tension in the rope, and I have mg 1 plus mr squared over I 1 minus 1 over I r squared m plus 1. But just mass times acceleration. Mass times acceleration is the tension force minus mg. Yeah, we have the same stuff. Did anyone set up an equation differently?
I did not. No. I think we all had a similar, if not the exact same idea. But
And they tell you what to apply, so. In our problem 2, we actually have numbers this time, and we have a heavy stick, and it's hanging on a low friction axle, and a bullet hits the stick. So it's going to translate and rotate. And we're going to find the final vector angular momentum, which I guess I just like ignoring vector maybe. About the stick and the bullet just after the collision. And
Yeah, that's mine.
I think we got all of the same answer.
Nice.
Yeah. Okay. So part 2, just after the impact, what is the angular speed? And it gives us the center of mass and the moment of inertia to use. So that's, we got the same.
Yeah, I got it wrong. I'm pretty sure that like I've checked the calculation. It's wrong.
Oh, okay.
Yeah.
Zach, did you get the same thing?
yeah, I got 0.0553. I haven't uploaded yet, but I do have it.
All right, that's fine. Part 3 is what is the torque exerted by the bullet on the stick if the time of impact in which the bullet comes to rest is 0.01 seconds. Show all the steps in your work. And I put system as stick and the surrounding is everything else. And I know that those two, we got 318.86, 318.77. I probably 318.9. That is really strange. We all got a different decimal place.
Like rounding.
Yeah. That is strange. Okay, but it's so close. We probably, yeah, we have the same reasoning.
Yep.
And for 4, I think for part 4, calculate the change in kinetic energy just before to just after the impact. Where is this energy gone? So I think it was pretty obvious. I used the energy principle. This is what I got. And I said that the kinetic energy of the system decreased because the internal energy has to increase, if it decreases. And looks like we all have the same answer, so.
Yeah, and because it's in like in inelastic collision, so some like heat from friction and from the collision. Yeah.
See, that's a better explanation. And part 5, the stick with the bullet embedded in it swings through a maximum angle. After the impact, it swings back. Calculate the maximum angle. Show all steps of your work. And let's see.
My calculation seems to be wrong. Like I checked the lecture and it seems to like be quite different from mine. So maybe some calculation error.
We all got something different. So
Yeah,
Yeah.
even I
Good.
got a different answer. I'm not confident in it, but I also got something different.
you got something different than the 3 of us?
yeah,
Oh
I
my
think I
God.
did. So yeah.
Okay.
I'm not 100% sure what happened.
Hmm.
Or, I mean, because like the steps look pretty similar. I'm not sure where we went different.
So we both agree. So it's swinging on its max. So its initial kinetic energy but when it reaches that max, its kinetic energy will be 0 because it like stops momentarily. And she agrees with that. And I agree with this. That's 0. Delta y is L/2. She's delta y, delta y. Me and Gia, I think, have really similar answers. I don't know how me and Gia got different answers. I think I must have calculated something. I must have punched the numbers wrong because we have the same formula. Do you have a different one? You have the same formula too.
That's weird.
Oh my God. What?
I don't know. This is almost more impressive that we managed to do this. Oh.
I know, we should get bonus. Obviously. We're all geniuses, forging our own
Oh,
paths.
yeah, for sure.
The problem, okay. I'm gonna make sure we have all the same stuff real quick. I'm gonna write this down on my pad. I just want to see if it really is the case.
I'm not confident in my answer, if that helps.
I'm never confident in my answer. I'm just like intuiting things, like I'm pretending to be like a psychic or something. I don't know the universe. Okay, something that's different here is this is a 2 and Alana has 1/2. Mass times, yeah, and these would have just canceled out. And that is something that this 1/2 MV is correct. I don't know where the 2 came from actually. 18 plus multiplied by 3 point. Yeah, and then this 3.1 isn't multiplied by the gravity and the weight of the small bullet.
Oh,
Calculate this answer. And then here, okay. I can't tell because I already calculated this value. That might be 1/2. I also have a 2 here that might not belong. 3.1, 9.8, the mass of the bullets.
Do you remember how it is from lecture?
Mm-mm.
Yeah, I don't know either.
Did you take it right from lecture?
No, I did not.
Oh, I was gonna say if you did, well, let's just go with yours. I still think I want to go with yours though.
I know. That one I kind of I just lost motivation.
Okay, well,
I can look it up in lecture though.
yeah, we might look it up after this,
Yeah.
but
Yep.
Other than that, do we have any issues?
No.
All right.